You started perfectly, Claire. You said, trying to find the limit as x approaches a. So, one second. I can't compare terms that are adding because x is not approaching infinity. So instead you chose to factor. We got to there. You would have a question to there. Okay. Then you said this is equal to what, Claire? 1. Are there any exceptions?
If x is equal to negative a.
Perfect. Does that make sense? Yeah. If x equals negative a, that will not equal 1. So again, if I had my xy pair list here, and I were plugging in x equal negative a, what would be the y coordinate, Claire?
0?
We'd end up with 0 here,
Yeah.
0 here as well. You with me?
Okay.
0 divided by 0 is undefined.
Yeah.
So this would be undefined.
Okay.
Again, don't ever worry about mistakes. We don't care. So, serious. So you're going to come back and tell me, we don't care about mistakes. How come you marked all those wrong on the test? We good to there?
Yeah.
Okay, awesome. Any questions to there?
Wait. What if you did negative a minus a is negative 2? And then you plug in negative a over x.
So here we would plug, so the question was, what's this equal to, Logan?
Oh,
And is there any value for x for which that doesn't equal 1?
oh.
0 is okay, because you put a 0 here, you get a over a, which is still 1. Negative a. So Claire noticed that. If you plug in negative a, this becomes undefined. Undefined times something is still undefined. So that's what happens there. But in terms of the limit, we're okay, because we're not going to plug in negative a. That's why this line is equal to this line, because of the limit. So once again, Claire, what's the purpose of the red formula?
You can find y as x almost equals
No.
approaching.
Find possible x and y pairs.
No. Say it. I heard it.
Find possible x and y pairs.
Find all of them.
Yeah.
Yep. Remember, don't forget, this is just a formula for some xy pair list.
Yeah.
The limit is separate. It's just something we're doing to that list. Good job, you guys.
Thank you.
Does that make sense? So this formula will find any of them. No restrictions. Can't forget that. But this formula is different. Someone tell me what's different about the green. Just raise your hand so we can follow somebody. Right.
It doesn't work for numbers that are like that x is equal to negative a, right?
Perfect. It works for all others.
Yeah.
In fact, that's really good news because I already know that when x equals negative a, the y coordinate is undefined. Good job. Well done.
Thanks.
If this formula will find all of the xy pairs except for this one, that means I'm going to stop using this because that's way too hard. I'm just going to use this. This will find all of the others. All of them. And the one we're looking for is which xy pair are we now looking for? When x is approaching negative 8. So we're looking for an x value that's perhaps a little bit less than negative a, and an x value that's just a little bit more than negative a. And we can use this to do it. So now it's just plug it in. So if we have close to negative a, I like addition. This would be like close to negative a added to another negative a. What do you have? negative 2a. So in both of these cases, the y value is going to get close to negative 2a, which means the value of this limit is negative 2a. But again, I want to keep talking until you're really comfortable, so don't hesitate to speak up. Like, I don't
Can
see
you say
it.
that one more time?
Huh? And
Like why they both
learning and editing. Hold on.
Ryan.
What is it? Ryan Porter.
Yeah.
There we go. I bailed out because I'm like, don't have any other Ryans. So, yeah, I want you to say it, so I'm going to kind of talk you through it, Ryan, then it'll stick better, I promise. Tell me again the purpose of the green formula.
Define x, y coordinates.
Which of them?
All of them.
Except
Except
except that one. That's why that's why I always tell you guys you have to use the equal sign. You have to tell the grader that you understand when things truly are equal. If you don't tell the grader, they're like, I don't know what they're doing. So you know that these two are equal because all we did was factor. These two are equal because that's equal to 1 unless x is negative a. But when we're finding a limit, we don't care about x equal negative a, so we're okay. So we can use this to find any xy pair other than this one, which you've actually already found, so who cares? We already know it. So we're going to do that. So we plug into this formula, we take away the x, and in place of the x, we plug in this value right here, close to negative a. You see it now, right?
Yeah.
Good. And we say, oh, those two added together, and they're almost exactly the same thing. So when we add them, we're going to get really close. This should be close, not exact, to negative 2a. Did that answer your question? Good work, right? Anybody else? Claire, you're okay?
Yeah.
Awesome.
Okay.
I want to finish the video here, so I'm going to do the next part of the problem, which is
Yeah.
find the horizontal asymptote. So these are just power functions, so we can just find out what happens as x gets positive, and the result will be the same for when x gets negative. Okay. Full ticket for this one. Okay, everyone in the room a full. That's why staying after school is so good. Okay, everyone in the room a full ticket. If you can precisely, you have to get it exactly right. To answer this question, like I'm looking for horizontal asymptotes. So I want to figure out what happens as x becomes 100, negative a million, negative a billion. Should I use the red formula? Should I use the blue formula? Should I use the pink formula? Which formula would be best to use, and how do I know that it's best? So let's wait for Sandra to think. So raise your hand if you know. I'll pay everybody knows, and I'll call on one person. Be our spokesperson. Let's go with Allie.
Is it the red one?
Tell me why.
Because you need the x squared and the x because as they get squared, they get bigger, but a stays the same because it's constant. And so you need to use the x squared and the x because they're bigger.
You're doing okay.
So you say like you look at the two things they're adding, which is x squared minus a squared, right? And so x squared is the bigger factor, whatever you call it in that. So use that one.
Term. Okay, bigger term.
Thank you. Term in that one. And then on the bottom, x is adding to a, and x is bigger because when x is at a million, it's bigger than a because a is constant. So you use x, and so then you're looking at x squared over x. And I think that's the one you use.
Stay with me. Oh, you're doing great. What you just did is you didn't think how I was thinking, but who cares about that? What? No, I'm serious. What? I'm serious. Because what you did is you thought about it in a different way that was completely correct. And
Okay.
you also did a really good job of explaining the why of all your thoughts. And that's what I'm always looking for. Like I'm trying to hear, like, does the person I'm talking with, are they doing the right thing, but do they also have the right reason?
Right.
Because the reason's most important. And so you were doing this, and you said, oh, this is going to equal this limit. And stay with me, Holly. So that, so far, so good. What would you do next?
Well, then if you're trying to find the horizontal asymptote, isn't that undefined? X squared over x for a horizontal asymptote? No.
Go ahead, Elizabeth.
Is there no?
Yeah, isn't there no for it? That's what I meant, but I don't know.
It's okay.
I'm lost at that point. Sorry.
Also, key to this class is being willing to say you're lost when you're lost. So don't even worry about it. No, really. Like, it's so much better when somebody just goes, I don't get it, versus just kind of fake it. 1 second, please. Sorry. What I would, okay, everybody look at me. What I strongly recommend, it will make a huge difference. Do this, like separate them. I do it all the time in class, just get used to doing it. What's this equal to? Say it. 1. Is there any x for which that doesn't equal 1? 0. Do we care? No. Because we're paying, so like Claire said, we're looking at this one. You said it earlier when you were in the back. We're looking here, right?
Yeah.
Awesome. So we don't care about that, so we can say this is equal to this. Okay, it goes back to the fundamentals. Just say it out loud. What's the purpose of the red formula? Yeah, I should have asked one person. Can't tell. Isaac Whitaker. What's the purpose of the red formula?
Find all the x vectors.
All of them. We did some work. We got this pink formula. Isaac, what was the purpose of the pink formula?
Find all the x vectors except when it equals -a.
Perfect. Allie, what's the purpose of that blue formula?
Find the y when x is approaching infinity.
Perfect. So now it's really easy because you can simply say, oh, I got it. If x is 100, what's y, Allie? 100. Because this is the formula for finding the y. It looks so simple you kind of miss it.
Yeah.
Does that make sense?
Yeah.
Yeah, it's saying this is the formula for finding the y. You just plug in the x. You do what Claire did. You say, oh, I plug in 100, the y is 100.
So as x is approaching infinity, the y is approaching infinity. It makes sense.
Does that make sense?
Yeah.
Perfect. So you write that down. You say x approaching infinity. Y is also approaching infinity. Because y is not approaching a single value, no horizontal asymptote. You don't ever use the word like undefined, non-existent for a horizontal asymptote. It's like it is or it isn't.
Right.
This one's not,
So
so
no.
just say no. And then you just check the other way. Because it was a power function, this analysis is the same if x were approaching negative infinity. So, Elizabeth, if x is approaching negative infinity, what's y approaching? Negative infinity, because you're just using the formula. I think you're picking up on my strategy here is to get you really good at understanding the formulas. Once you start to see that, the whole process becomes ultimately so much easier because you're no longer worrying about all these little weird steps. You're just like, oh, I just got to get the right formula, then I'm good. That's all it is. I trust you to be honest. Allie said we should have done, used this formula, right, and do this process, and she was right. There's nothing wrong with that. I was actually thinking something different. My thought was, because Isaac told us that this formula works for all x, like we could just, oh, you're doing that too. Awesome.
Yeah, because can't you just use that one to find it since the only value you can't have is the negative a, so the
Yeah.
infinity wouldn't matter.
Yes. That's what I was thinking. I'll pay you as well, don't worry. So I was thinking, oh, well, let's don't do new analysis. And it doesn't matter. Either way is fine. But my thought was, rather than do something new, just use this. Because it works for all x, except x equal negative a. So then I just say, oh, well, if x is a billion minus a is really close to a billion. So the same thing happens. As x grows, y grows. It's good work. So if you just be honest and I'll pay you. If I would have called on you and you would have either done what Allie did or what Clayton did, I'll pay you. There's never reason to be dishonest in this class because the test will show everybody's honesty or not. Before I stop the recording, anything else on 6 anyone wants to ask about? Cool.